we are going to see about some of the numerical in bolted connection. So first we will find out how to find out the strength of the bolt. So strength of the bolt equal to the minimum value among shearing strength of the bolt as well as bearing strength of the bolt. So first we have to find out shearing strength of the bolt. So after that we have to find out bearing strength of the bolt. So after that finally the strength of the bolt will be equal to the minimum value of these two. So how we will calculate the shearing strength of the bolt? So shearing the strength of the bolt or design shear strength of the bolt, that is VDSB equal to VNSB divided by gamma MB. Nominal shear strength of the bolt divided by partial factor of safety, gamma MB is 1.25. So VNSB equal to FUB divided by root 3 NN into ANB plus NS into ASB. Okay. So here ANB equal to net area of the bolt, this is 0.78 pi d squared by 4, 0.78 pi d squared by 4. So what is this ASB? ASB equal to shank area of the bolt, the area of shank equal to pi d squared divided by 4. Okay. So this is FUB. FUB means ultimate tensile strength of the bolt. So here NN means it is depends on number of shear plane. So number of shear plane passes through the thread of the bolt means we have to consider this term. If the number of shear plane passes through the shank area of the bolt means we have to take this term. So always we have to assume critical one. So always we have to assume shear plane passes through the thread of the bolt. So this term always becomes 0. So we have to consider this term only. So if it is the lap joint NN equal to 1, if the lap joint means NN equal to 1 because the only one shear plane is there, NN equal to 1. If it is a single cover butt joint also we have to take NN equal to 1 and double cover butt joint NN equal to 2. Now we will see one problem. Calculate the strength of 20 mm diameter bolt of grade 4.6 for the following cases. The main plates to be jointed are 12 mm thick. So the main plates thickness is 12 mm, bolts of grade 4.6 and 20 mm dia. So here D equal to 20 mm. 20 mm. We need to calculate D naught also. D naught equal to D plus clearance. D plus clearance. So already I have explained up to 24 mm the clearance is 2 mm. This value is available in IS 800-2007 also. So up to 24 mm clearance equal to 2 mm. So D naught equal to 22 mm. D naught equal to 22 mm. So now coming to the question, lap joint. Okay, for the lap joint what is the strength, and single cover butt joint and double cover butt joint. Okay, this all three cases we have to find out the strength of the one bolt. So take plate of 410 grade, this is the plate strength. Using this data we can find out the FU. FU means ultimate tensile strength of the plate. FU means ultimate tensile strength of the plate. Ultimate tensile strength of the plate is 400 megapascal, otherwise 400 Newton per mm square. Now coming to here, grade 4.6. What is grade 4.6? This is the bolt grade. Grade of bolt material 4.6. So here we want only the FUB. What is FUB? Ultimate tensile strength of the bolt. So here the first term, what is the first term? First term is 4 multiplied by 100, we can get 400. So 400 Newton per mm square. 400 Newton per mm square. So this is the ultimate tensile strength of the bolt. So these are all the given data. D is 20, D naught equal to 22. Using plate grade we can find out the FU. FU equal to 410 mm square, Newton per mm square. Coming to the bolt of grade 4.6, that is FUB equal to 4 into 100, that is 400 Newton per mm square. So these are all the given data. Gamma MB, that is partial safety factor for the material of bolt, gamma MB equal to 1.25. So in table 5 it is available, gamma MB 1.25. At site, at shop also 1.25 only gamma MB. So now first case is lap joint. First case is lap joint. So coming to the lap joint. So we know that lap joint is single shear. Okay. So this is the lap joint. This is one plate and this is another plate. Okay, we have to keep over one another and we have to connect using bolt. This is lap joint. So here only one contact surface is there. So this is the shear plane. So always the shear plane is parallel to the applied load. This is the applied load and this is the applied load. This is the applied load. So this is the shear plane which is parallel to the applied load. Okay. So this lap joint is subjected to single shear. So now first we have to find out the design shear strength of bolt. So we know the formula VDSB equal to VNSB gamma MB. So VNSB equal to VNSB, what is the meaning of VNSB? Nominal shear capacity of bolt. Nominal shear capacity of the bolt VNSB equal to FU divided by root 3 NNANB plus NSASB. This is general equation only. So general equation only. So here we have to assume shear plane passes through the thread portion of the bolt. Shear plane passes through the thread portion of the bolt. So here shear plane passes through the thread portion of the bolt. So if we assume this one, this term will not come. Okay, this is the shank area. Shear plane passes through the shank area means we have to consider this one. Here we have to assume, always we have to assume shear plane passes through the thread portion of the bolt, not shank area. Okay, not shank area. So here, so Nn equal to 1. Nn equal to 1. For example, this is the lap joint. Okay, this is the lap joint. So here we assumed shear plane passes through the thread portion. So what is the thread portion? For example, this is the thread portion. This is the thread portion and the remaining is shank area. So this is the thread portion, this is the shank area. So now I think this is the lap joint. See here, this is the lap joint. This is the lap joint. Okay. So this is the bolt. So here, see here. So here this thread portion. These are all the thread portion. No, this thread portion passes through the shear plane. Here, how many shear plane is there? Only one plane is there. In the lap joint, only one plane. So Nn equal to 1 and Ns equal to 0. Okay, for the lap joint, Nn equal to 1. So what is A and B? Next one, what is A and B? A and B equal to net area of the bolt, which means what is the net area? What is the net area here? This is the thread portion, no? So thread portion 0. As per the code, the net tensile stress area, net area of the bolt in the threaded portion equal to 0.78 pi d squared by 4. So here D equal to dia of the bolt. D equal to dia of the bolt. So dia of the bolt equal to 20 square. So 20. And substitute here 0.78 pi d square divided by 4, we can get the answer. So after that substitute in this equation, FUB, already it is available. FUB means ultimate tensile strength of the bolt. It is based on the grade of bolt, that is 4.6 means 400. So substitute 400 divided by root 3 and Nn equal to 1 and ANB equal to 245 mm square. Okay. So now after that divide by gamma MB, partial factor of safety, that is 1.25, we can get the answer VDSB equal to 45.26 kilonewton. So this is the shear strength of one bolt, So now we have to calculate what is the bearing strength of bolt, because it is subjected to shear as well as bearing. So this is the formula. Bearing strength of bolt equal to VDPB, design bearing strength, equal to nominal bearing strength of the bolt. N means nominal. Okay, nominal bearing strength of bolt divided by gamma MB. Gamma MB equal to partial factor of safety of the bolt. So now coming to VNB. Okay, we can use this formula to find out VNPB. So VNPB equal to 2.5 times of KB. KB is K suffix B is one constant and D equal to dia of the bolt. T means minimum thickness of the plate. For example, so this is lap joint means here one plate is there and here one plate is there, two main plates are there. So this is 10 mm thickness and this one is 8 mm thickness means, okay, we have to take the minimum value. Okay, so here the answer is 8 mm. This is example only. Okay. So now our problem, what is T? 12 mm. Here main plates to be jointed at 12 mm thickness. 12 mm thickness. Yes. So now coming to here, T equal to here 12 mm. Both the plates are having same thickness as per our problem. So T equal to 12 mm here. T equal to 12 mm here. T equal to 12 mm as per the given data. What is FU? FU means ultimate tensile strength of plate. So plate means 410 Newton per mm square. So now only one thing we have to calculate, that is K suffix B, this is the constant. So this is also given in the code book, that is minimum of E divided by 3 D naught and pitch divided by 3 D naught minus 0.25. After that FUB divided by FU, after that 1. So we have to take minimum value among these 4 cases. So what is E? E equal to edge distance. How we can calculate the edge distance? Already we know how to calculate the minimum edge distance and minimum pitch distance. Here we have to use minimum edge and minimum pitch because there is no data available in the questions with respect to edge as well as pitch distance. Now coming to edge. Edge distance or end distance equal to 1.5 times of the D naught. 1.5 times of the D naught. So next one, pitch distance. Pitch distance equal to 2.5 times of the D. So this both values, minimum values only, minimum. E minimum and P minimum. E equal to 1.5 times of D naught, we can get the answer 33. So D naught equal to 22 mm. Pitch equal to 2.5 into D, D equal to 20 mm and find out the value and substitute here. So for E divided by 3 D naught 0.5 value, P by 3 D naught minus 0.25, pitch is 50 and 3 into D naught equal to 22 mm minus 0.25, we can get 0.5 answer. And FUB divided by FU, what is FUB? FUB ultimate tensile strength of the bolt, that is 400, that is given in the problem. Next FU equal to 410, ultimate tensile strength of the plate. This will be equal to 0.975. The final value 1. So we are having 4 cases. Which one is minimum? 0.5 is minimum. So now K suffix B equal to 0.5. K suffix B equal to 0.5. So substitute this KB value. Substitute the KB value in this equation and find out the VDPB, that is design bearing strength of the bolt 9.84 kilonewton. Now we are having two values. One is shear strength of the bolt, another one is bearing strength of the bolt. So now our aim is we have to find out the strength of the bolt. So strength of the bolt we have to select minimum value between this one and that one. So now the strength of the bolt will be minimum of the strength in shearing and bearing. So strength of one bolt equal to 45.26 kilonewton, because this more than this load the bolt get failure. So we have to take the minimum one. Strength of one bolt equal to 45.26 kilonewton. So this is the first case. Now coming to the second case. Single cover butt joint, the cover plate being 10 mm thick. So, this is the single cover. So, butt joint means this is main member, we have to place another main member here, okay, and this is one cover plate. Through this cover plate we have to connect this to main plate. The cover plate thickness is given, that is 10 mm. Main plate thickness already given in the problem, that is 12 mm. Main plate is 12 mm thickness, okay. So, this is single cover butt joint, okay. So, here how many shear planes are there? See here, only one contact surface is there. So, here n number of shear plane equal to 1. Okay, this is similar to the lap joint only, no need to solve again, because the only variation is n only. N here also 1, in previous case also 1. If you use the formula, we can find out the answer, VDSB equal to 45.26 kilonewton. Now, coming to the bearing strength of the bolt. So, here same formula, VDPB equal to VNPB divided by gamma MB. So, here VNBP equal to 2.5 kb d TFU 1.25. So, what is the difference between this case and previous case? Only the thickness. So, here two different types of thickness are there. One is the thickness of the main plate, another one is the thickness of the cover plate. So, here T equal to the minimum value of this two. Which one is minimum value? 10 mm is the minimum value. So, here we have to substitute T equal to 10 mm. In the previous case only one thickness is available, so that is why we have selected the 12 mm. In that case two thicknesses are there, one is 12 mm, another one is 10 mm. In that we have to select the minimum thickness. So, 12 and 10, the minimum is 10 mm, and substitute here and find out the answer, okay. So, the T equal to aggregate thickness of the cover plate, aggregate thickness. Here we are using only single cover only, so only one thickness. After that minimum thickness of the main plate, so T equal to 10 mm. Substitute in the formula and find out the answer, that is the strength of bolt equal to 45.26. In that also shearing strength is 45.26. Okay. Shearing strength is 45.26. What is the bearing strength? Bearing strength is 82.0 kilonewton. So, which one is minimum? 45.26. So, the strength of one bolt equal to 45.26 kilonewton. Now, coming to the third case. What is the third case? Double cover butt joint, each of cover plate being 8 mm thick. Double cover butt joint. So, place the main plate like this, okay. So, place the cover plate on the top as well as bottom, because this is double cover, this is one cover and this is the second cover. So, the cover plate thickness is given, this is 8 mm and this is 8 mm. Main plate also given in the question, that is 12 mm. Okay. So, this is the cover plate. So, as usual, for finding the strength of the one bolt, first we have to calculate the shear strength of the bolt. So, here how many contact surfaces are there? The one is this one, another one is this is the contact surface, this is the shear plane, this is the shear plane and this is the another shear plane. So, here number of shear plane equal to 2. So, always we have to assume shear plane passes through the thread of the bolt, because the thread area is the critical one, because compared to the shank area, thread area is very less. So, we have to assume only thread area, because with respect to this point nothing is there in the questions. So, we have to assume, if it is given in the question, take the shear plane passes through the shank area, means no need to consider this term, consider this term. N is equal to 2, EASB equal to area of the shank, that is pi d squared by 4. Now, here assume shear plane passes through the thread, because this is the critical one, no. So, here 2 shear plane is there, so Nn equal to 2. So, this term won't come, that is Nn equal to 2 and ANB equal to 0.78 pi d square divided by 4, d equal to 20 mm. And substitute here and find out the answer. that is 90.52. So, coming to bearing strength of bolt, this is the shear strength of one bolt 90.52. Now, coming to bearing strength of bolt, so same formula, what is the difference? T. So, here we are having two types of thickness. What is the two? One is thickness of the main member, another one is thickness of the cover plate. So, T equal to minimum, already we have seen here. So, aggregate thickness of the cover plate. So, here aggregate thickness is 8 plus 8. Minimum thickness of the main plate is 12 mm. So, this is 16 mm. So, now T equal to the least of these two one. Which one is least? 12 mm is least. So, we have to substitute 12 mm here. Substitute 12 mm here. So, now bearing strength of bolt equal to 98.4 kilonewton. Which one is minimum? Shearing strength or bearing strength? This is shear strength is 90.52, bearing strength is 98.4. Again strength of bolt equal to 90.52. This is the least value. This is the least value. Now, coming to strength of connection. So, in the previous case we have seen how to find out the strength of one bolt, strength of the bolt. So, now here strength of connection or joint, strength of connection or joint. So, strength of connection means in the connection plates also involved and bolt also involved. So, here we have to find out strength of the bolt also and strength of the plate also. So, minimum value of these two cases, bolt strength as well as the plate strength. Already we know how to find out the bolt strength and plate strength. We have to use this two formula, plate strength equal to minimum. So, the plate is subjected to two types of failure, one is cross section yielding, another one is net section fracture. Cross section yielding and net section fracture. So, for the cross section yielding, this is the formula. So, this formula derived from stress equal to load by area, this is the load equal to stress into area. So, yielding means yield stress and cross section yielding means AG. AG means area of the cross section, gamma m naught, the partial factor of safety with respect to yielding. Now, coming to TDN. TDN equal to 0.9 AN FU gamma M1. AN means net area, same formula, load equal to stress into area. So, this is net section fracture. So, multiply by 0.9 divided by gamma M1. This gamma M1 the factor of safety with respect to net section fracture. So, this is also available in our code book IS 800 2007. So, some of the textbook they have considered only this one, because always we can get minimum value this one only compared to cross section, So, we can consider only this value, no need to calculate TDG. If we calculate also no problem. Okay. So, now what is the gamma m naught? Gamma m naught equal to 1.1 and gamma m1 equal to 1.25. Gamma m naught partial factor of safety governed by yielding. For yielding, gamma m naught equal to 1.1. For net section fracture, the partial factor of safety is 1.25. So, here coming to net area of the plate. So, this is with respect to plate strength, no. So, here we need to calculate AN. What is AN? Net area of the plate. What is AG? AG means gross area of the plate, So, now coming to chain bolting. For chain bolting, so pitch is equal. Here all the rows pitch is equal. So, AN equal to B minus NDH into T. So, how we can calculate the area of the plate? Breadth into thickness or width into thickness. So, B into T. So, this is the B. This is the B. This portion equal to B. So, in the B, okay. So, here two bolts are there, okay. So, we have to subtract this whole area, D naught area. So, we can get the remaining area, this one and this one and this portion we can get. This is called as net breadth area. So, net breadth, otherwise net width, okay. So, that is why we have to subtract by minus NDH. What is N? N means number of bolt, N means number of bolt, DH equal to dia of the hole, otherwise we can calculate D equal to D into DH or D naught. Okay, both the symbols are equal, D naught or DH, both are equal only. So, D plus clearance. So, this is the clearance, D plus clearance. This is available up to 24 diameter, the clearance is 2 mm, clearance is 2 mm. This is the clearance. Now, coming to the staggered bolting, that is zigzag bolting. So, this is like this, different pitches are there. So, see this figure. So, this is one pitch, here to here one pitch and here to here second pitch, cause also difference. So, in that case we have to use this formula, breadth of the plate minus NDH, number of bolt and diameter of the hole, and summation of I 1 equal to m, pitch 4 GI. If 2 pitches are there means P1 plus P2, cos 2 means 4 G1, which means P1 divided by 4 G1 plus P2 divided by 4 G2 into thickness, we can get the answer. Another one thing is efficiency of the joint. Efficiency of the joint means strength of bolted joint. Strength of bolted joint divided by strength of solid plate. How we can calculate the strength of bolted joint? Strength of the joint equal to, this is the formula. So, minimum value of bolt strength as well as the plate strength, we have to calculate strength of the joint and divide by strength of solid plate. Strength of solid plate means that is the strength equal to gross area into stress divided by partial factor of safety into 100, we can get the efficiency of the joint. Now, coming to this problem, find the efficiency of lap joint shown in figure, given M20 bolts of grade 4.6 and Fe 410 plates. This is the lap joint. So, this diagram also given. Okay. So, using this diagram, write down the given data. D is given. What is D? This is the mean diameter. M20 means mean diameter. So, here D equal to 20 mm, this value, mean diameter M20. 4.6, using this value we can calculate ultimate tensile strength of the bolt equal to 400 Newton per mm square. So, this digit into 100. Now, coming to Fu 410, that is Fu, this is the plate strength, Fu equal to 410 Newton per mm square. So, what is the pitch distance here? Pitch equal to, this is the 60 mm. Okay. Here pitch also, edge also given, no need to calculate minimum pitch, minimum edge distance. This is 30 mm. E equal to 30 mm, pitch equal to 60 mm. So, these are all the given data. Now, so first for finding the efficiency of the joint, so first we need to calculate strength of bolted joint. Okay, strength of bolted joint. For the strength of bolted joint, we want the bolt strength as well as plate strength. After that, we have to take the minimum value. The first one is design strength of one bolt. Design strength of one bolt equal to, that is lap joint. No, we know that lap joint subjected to the single shear. Use the same formula, that is VDSB equal to VNSB divided by gamma MB. So, VNSB equal to FUB divided by gamma MB root 3. With respect to this data, nothing is there in the question. So, always we have to assume shear plane passes through the thread of the bolt. Shear plane passes through the thread of the bolt. So, then this term won't come. So, this is the lap joint. So, Nn equal to 1 and ANB equal to 0.78 pi d squared by 4, D equal to 20, and substitute and find out the answer. So, VDSB equal to 45.26 kilo Newton. Now, bearing strength. So, bearing strength, same formula, that is 2.5 kb dt Fu gamma mb. Here no need to calculate the minimum edge distance and minimum pitch distance, because this data is available in the question. This data is available. Edge distance and pitch distance are available in the question, that pitch equal to 60 mm and edge equal to 30 mm. So, substitute these values in the formula, substitute these values, okay, and find out the smaller value kb, smaller of any one value. Okay. So, here which one is small value, that is 0.45, and substitute here and find out the answer. Here T equal to thickness of the plate. So, here two members main plates are there, no, both are same thickness, 20 mm and 20 mm. So, use 20 mm here. Okay. Use 20 mm here, this is the thickness, and find out the value is 147.6. 147.6. So, the strength of one bolt, the which one is minimum, shear strength is 45.26, bearing strength is 147.6, the minimum is 45.26. This is the strength of the one bolt. So, here number of bolts also given in the question, number of bolts also given in the question, that is how many bolts are there in the one plate. This is one plate, this is the one plate. So, here 2 rows are there, that is 1, 2, 3, 4, 5, 6, 6 bolts are there. Now, we have to find out strength of 6 bolts. Okay. So, 6 into strength of 6 bolts, 6 into 45.26, so 271.56 kilonewton. Now, coming to the plate strength. So, no need to consider cross section yielding. If we consider also, we can get the minimum value, this one only. So, TDN equal to 0.9 ANFU gamma M1. So, this is the net area of the plate, net area of the plate. So, AN equal to B minus NDH into T. We know that DH equal to 22, T equal to thickness of the main plate 20 and B equal to 180. What is N? So, B. So, 60 plus 60 plus 30, 30 we can calculate the B. So, this direction how many bolts are there? 1, 2, 3. We have to deduct this 3 bolts. The whole of 3 bolts, that is 3B minus NDH into T. So, this is the with 180 minus N equal to 3, D not equal to 22, T equal to 20 mm. So, find out net area and substitute here and find out the answer, that is 673.05 kilonewton. So, here what is FU? FU equal to ultimate tensile strength of the plate, that is 410 Newton per mm square, and gamma ML equal to 1.25, partial factor of safety with respect to net section fracture, that is 1.25. So, substitute here and find out the answer. So, now coming to the strength of the joint. What is the strength of the joint? So, the minimum value of this one, strength of one bolt and 73.05 TDN. Which one is minimum? This is the strength of 6 bolt and this is the strength of the plate. Which one is minimum? 271.56 is the minimum. So, strength of the lap joint equal to 271.56 kilonewton. Now, coming to efficiency of the joint. How we can find out the efficiency of the joint? We know the formula, strength of this lap joint. What is the strength of the lap joint? That is 271.56. Strength of the solid plate. So, using this formula, solid plate means no need to subtract the bolt hole. We have to consider the gross area AG. That is how we can calculate the AG. AG equal to width into thickness, B into thickness, B equal to 180 and thickness of the plate equal to 20 mm. In the previous case, we have deducted the D naught. Okay. So, here no need to deduct the bolt hole diameter, only we have to consider the entire solid width. Divide by gamma M1, that is 1.25. So, find out, that is 1062.72. This is the strength of the lap joint and this one is strength of the solid plate. Divide by solid plate into 100, we can get the efficiency. Okay. So, now we have completed the 2 problems. We have completed the 2 problems. One is strength of bolt, another one is strength of the joint, and third one is, third formula is efficiency of the joint. Okay, thank you. We will see in the next class.